So today we will be talking about classes and objects. Now, we've talked about it briefly before and we've been interacting with them, so this should not be entirely new to you because this whole time we've been using a class, public class, assignment 2, or whatever it may be. We've always had a class. And we've been using objects too. This random number generator is an object. So when I create this, it creates an object, and you even see it up here, it says object. It creates an object in memory based on the random class. Okay, so the random class acts as a template. Then when we actually run our program, we create objects of that template so that we can use it. For example, we can't just use the class name like this, random, and then try to do random.nextInt. We can't do that. We have to create an object of this class in order to use it, and we'll talk about that today. I have some slides now. Okay. So, classes. Again, classes are like templates, right? We basically provide the spec sheet for what we want our object to look like, and then when we actually want to use that class is when we create an object. So again, it essentially acts as a template. Each class contains data fields that can be altered or manipulated. However, the value of those attributes will change for each. Oh, for example, each vehicle contains common attributes such as make, model, year, VIN, whatever it may be. But when you actually have a real car, the value of those attributes are different for each individual vehicle. So for example, we have vehicle 1, vehicle 2. They both have common attributes. Make, model, year, and VIN. However, when we have the real vehicle, these values are going to be different between the two, right? Maybe it's just a VIN, or maybe they are identical objects. It doesn't matter. When we actually create the object itself, the values of those data attributes will be different and unique to that object. All right, so classes again. We can specify the attributes we want that class to have, then create objects of that class and fill in those attributes. And I'll show you examples of this as well. So here's an example of a vehicle class. You see, this class doesn't have a main. It doesn't have anything else in it. It's just a template, all right? That's all it is a template. And in that template, we have the name of the class, and then the attributes we want that template to have. So we specify the name of the class here. It should always be capitalized. The first letter should be capitalized of a class. And then each letter of every subsequent word in that class should be capitalized as well. For example, if I have another class down here, public class, lecture 3. You see, I capitalized the first letter of the first word and the first letter of each subsequent word. So if I had more words after this, each one would be capitalized. Versus if this was a variable, I would lowercase this first letter and capitalize the rest. So that's a naming convention for Java. And we specify the attributes here. So these are all the attributes of my class. All right, and this really establishes the foundation of object-oriented programming. So if you learn this in Java, you can do this in essentially any modern programming language. So the techniques I'm teaching today and what I'll be teaching in this class can be applied to Python, can be applied to Swift, Objective-C, whatever it may be. All right. So when we create objects, again, we're creating a physical representation of that class in memory so that we can actually use it. So with classes acting as our template, we can create objects and manipulate them. We declare an object like we declare any other variable, except the data type will be the class that we want. So for example, with other variables, we do int, number, versus we want to declare an object, or we want to declare that we're going to create an object of this. We do the object type or the class type, and then we do the name. So similar to any other variable. Then we actually create the object or instantiate it using the new keyword similar to an array. So Mustang equals new vehicle, right? The previous slide, we declared the object, and on this side, we actually instantiated it. Again, just like any other variable, you can do all of that on one line, just doing vehicle Mustang equals new vehicle. It doesn't matter how you do it. You may want to declare it somewhere, and based on a certain given logic, the actual object that you're creating changes. We'll talk about that later when we talk about inheritance and polymorphism. So I just want to provide some examples, and then we'll go through some code of classes and objects so that it better represents what I'm talking about. So the class is the spec sheet, right? It's basically the template. It has all these different attributes according to, you know, whatever the person says. So let's say a car. For the class is the spec sheet. It has, you know, the engine type, the horsepower, the torque, the platform, the drivetrain, all that different information. The actual object is the real world Mustang that we get to drive and use. Okay. The class is like the template or the spec sheet. The object is the real world Mustang. So what does this look like in code? So we create our vehicle class, string make, model, year, engine, power variant, or just power, whatever we want in here, right? And then we actually create an object of it. We say vehicle Mustang equals new vehicle. We create the object, and to access all those attributes, we just do Mustang.make equals whatever. Mustang.model equals whatever. So that's how you access all those attributes inside an object. You do the dot and whatever the attribute name is, okay? And here, again, we create the class with the vehicle properties, and then we instantiate the object over here. And this is the full example of that. So let's see what that looks like in code. All right. So let's create our class first, and then this is going to be a little bit different than what you'll do and what we'll do in the future because I'm using a visualizer. But in the future, we'd want to put our classes into different files, right? Named after that class. In the visualizer, I can't use multiple files, so I'm going to put everything in the same object or in the same file, if you will. And so what you can do in Java is make nested classes, which is what I'll do. So inside of the assignment 2 class, I can do another public class vehicle. And this vehicle has a make, model, year, engine, and power. String make, string model, and year, string engine, and then string power. All right, you see I just created a class. It has all these templates or all these data attributes that I want to use as part of my template. So to actually use this vehicle inside my main, I say vehicle Mustang equals new vehicle. And I just created an object. And since I'm accessing this from the main, and this is not in a different file.
Mr. Brown, is it okay if I go to the restroom real quick?
Yeah, that's fine.
Okay.
Since I'm accessing this from the same file and from the main, I do need the static keyword. The main is funny about that. All right, so you see here, I have vehicle Mustang equals new vehicle. And what happens is it creates an object of that vehicle with all these data attributes, right? And there you go. Then the program ends, okay? So now we have our Mustang class or our Mustang object, and it points to an instance of a vehicle, right? An object. Does that make sense? Classes versus objects.
Yes, sir.
All right. So we go further, and we could change those attributes just by using their names. So Mustang.make equals Ford. Mustang.model equals Mustang. Mustang.year equals 2021. Mustang.engine equals V8 supercharged. Yeah. 5.2 liter supercharged V8, and then Mustang.power equals 720 horsepower at, I think, 8,200 RPM or 7,200 RPM. 7,200 RPM. All right, so now we've set the variables or the attributes of that class equal to whatever we want. This could be whatever we want. It could be Camaro, it could be, it doesn't matter, Chevy, Tahoe, it doesn't matter. We name it something else, and I'll create another. So system.out.println Mustang.model. I just want to print out the model. All right. So we create our vehicle. Again, it creates that class, creates the object, and we have our Mustang object. We set the make equal to Ford, the model to Mustang, the year to 2021, the engine to 5.2 liter supercharged V8, and the power to 720 horsepower at 7,200 RPM. Then we print out the model. I just want to print out the model so we see what that is. All right. And there you go. And again, we can create another one, at least I believe we can. We'll see what happens, because since this is a static class up here, it may be an issue, but we'll see. Vehicle Tahoe equals new vehicle. Tahoe.make equals Chevy. Tahoe.model equals Tahoe. And the Tahoe.year equals 2021. Tahoe.engine equals, I think it's a 5.2 liter V8. Tahoe.power equals, I don't know, 450 horsepower. And then we system.out.println Tahoe.model. Right? I want to print that out as well. We'll see if this works, since this is a static class. So we create our Mustang object, we set all of our attributes, and we print out the model. Then we create our Tahoe object, and good, it did work. So it created a separate object. Right? These are two different objects. One named Mustang with these attributes, one named Tahoe with these attributes. And we go through. We set everything equal to those characteristics, and we print out the model. All right. Any questions? Again, I don't know how many times I have to tell you all, I do need to see your faces during class. Just having your camera on is not good enough. All right. So Gabriel, Doriantis, Nate, Mike, I need to see you all's faces. Or you will be marked absent. All right, let's go through one last example and we'll call it a day. Let's go through a fruit example, right? So again, with fruit, instead of having, make, model, all that stuff, that's really unique to a car, we have our nutrition facts. And really with any food item, we have nutrition facts, right? So the nutrition facts label and all these different attributes would be our class. When we actually create the fruit and we actually want to eat it and it has, those attributes, that's our object, all right? So in code, we can create a fruit class with all these different attributes. And then when we want to create an actual object, we use we actually use the new keyword, create the object, and then set all of the attributes over here. All right. So create a class with vehicle properties, and then we create our object. And here is our full example. We have a fruit class, and then we create an object in the main. Let's go through this example with actual code. I want to use NetBeans. So hold on a second. Let me try to get this NetBeans working. I don't know why it's being so difficult. This is the only issue with NetBeans. It's very particular. Let's see. Hold on, give me a second. I'm going to just take this code right here. So all these different attributes of a fruit. And of course, it may have more than this, but this is just the ones for this example. And then we can create an apple using those attributes. So we create our fruit object. And let's print out apple.variety. Okay. Let's see what that variety is. All right, so again, we create our public static class fruit. It has these different attributes. Again, the class acts as a template for whatever object we want to create. And we can visualize this. So the first line, we go to our main. First line is to actually create that object, apple, and it has all these attributes. We set these attributes equal to these values, then we print out our variety. And that's it for this program. We can do this again. Let's do an orange instead. Orange. Instead of apple, we want to say orange. If we kept apple here, it would obviously change our apple object. It wouldn't change our orange apple, our orange object. Orange, let's say acuity. Let's change these values. I don't know. Who knows? And then we do orange dot variety. And you'll see we have two completely separate objects. We have our first one is our apple, but do keep in mind each one of our objects are instances of fruit, right? They're both fruit objects. We've just named them different things, and we're setting their attributes as a result, right? So we have apple fruit instance or fruit object, and then an orange fruit instance. They are both fruit, but we've set their attributes equal to different values. Then we print out the variety just because. All right. Any questions? Classes and objects. We'll go a little bit more in depth next time, but I wanted to give you just a pretty brief introduction to what a class versus an object is. And again, that establishes the foundation of all object-oriented programming. So JavaScript, C#, C++, Objective-C, Swift, Python, Java, all of these different languages, and most of the languages you'll encounter today are object-oriented. They have classes, and then they have objects of those classes. And those objects are how you manipulate them and how you set templates, and a lot of different things. You have something called inheritance, where one class inherits from another, so on and so forth. So there's a lot of different things you can manipulate with object-oriented programming. And we'll talk about that once we'll talk about what the foundations are once we get through this inheritance, something called abstraction, and polymorphism. All right. It is abstraction, polymorphism, inheritance, and encapsulation. Those 4 keywords, and we'll talk about those a lot throughout the semester, are the 4 pillars of object-oriented programming. Once you get those 4 concepts down, you can learn for the most part, any language out there, and all it takes is learning the syntax or the language of that programming particular language. All right, so in Java, we have to say it like this. In Python, to create an object, it's a little bit different. You don't have to do all this. In C++, you have to do a little bit more. It's just learning that particular syntax, but if you know the foundational concepts, which are those 4 pillars: abstraction, encapsulation, polymorphism, and encapsulation, polymorphism, abstraction, and inheritance. Once you know those 4 concepts, you'll be good to go. All right. Any questions about this, classes and objects? All right. If there's no questions,
No, sir.
all right, cool. If there's no questions, we are good to go. I will see you on Wednesday.
All right, have a good day.